I just wanted to take a minute. This is another opener that could help us kind of get ready for the test. And I don't really want to solve all of these things and get the points, but I just wanted to point out a couple of things and maybe just get the justifications down. You'll see here I've graphed the original function in red, the derivative in blue, and the second derivative in green. Okay. On this question, you look at this equation, you shouldn't be expected, you're not expected to know how to find the zeros, so you could use your calculator here to get those zeros. Here, f prime, the derivative, is negative sine x minus 12x plus e to the x. So critical points, remember, is where the derivative equals 0. Okay, so we're going to have some critical points where the derivative is 0. I'm just going to put some dots here. So we get a critical point there. Oh shoot, we got another one out here. I cut it off. But those are the critical points. I'm just going to put blue. Okay, they're the blue dots. Okay, now this critical point right here, the derivative changed from positive to negative. See that? The derivative was positive, then negative. That makes this a maximum. Okay, in the original function. Now, you can see that in the original function, it is a maximum. Okay. Over here, the one I accidentally cut off, if it continued up, and it does, it continues up like this, the derivative changes from negative to positive, making this represent a minimum. Okay. And of course, our justifications, I don't have a lot of room. F prime of x changes, and you kind of fill in the rest. The interval where the function is increasing, well, remember that is any time the derivative is positive. So we just go down and we look for the spots where our derivative is greater than 0. So of course we get some over here, right? There's going to be some over here if we had the whole graph. So we just put those as intervals. Concave down, remember, means that the second derivative is negative. Okay, so we look and you can see here the second derivative all the way along here to 2 point something is negative. So again, we'd have an interval. We'd say, oh, the second derivative is negative, so it's the function is concave down. And you can, I hope, see that, the original function is in red. You can see it's concave down this whole time. It's opening down, and then right over here is where it would change and begin to be concave up. Okay, so this is where the derivative is concave down. Remember, you could also, or the function, you could also classify it as when f prime is decreasing. Okay. Finally, f is on the interval from -3 to 3, find the absolute maximum. Well, this means we got to use candidate tests. So we're going to plug in -3, we're going to plug in 3, and we're going to plug in that critical point, which if you calculated this critical point right here, it is 0.084. I did that on a calculator, just using the calculate feature. So you could just plug all of these into the original function and see which gives you the largest value. Again, this is just real quick. We've done these before, but I wanted to do just kind of some talk on how we'd use the derivative.